Thank you for always being there with us. This is Chemistry with Chris. In this lesson, we still continue with our gas laws, but in today's lesson, we are looking at ideal gas equation. Ideal gas equation. What are ideal gases? Ideal gases are gases that obey Boyle's and Charles law. Ideal gas or ideal gases are gases that obey Boyle's and Charles law. Now, how do we derive ideal gas equation? The ideal gas equation is derived from the combination of Boyle's, Charles, and Avogadro's law. We have looked at Boyle's law in the previous class. We have looked at Charles' law in the previous slide, but we've not done Avogadro's law, which may be our subsequent law that we are going to be looking at maybe after this episode. So now, what does Boyle's law say? If you combine Boyle's, Charles, and Avogadro's law together, what you have is the ideal gas equation. And I say ideal gases are gases that obey Boyle's and Charles' law. Now, you recall that Boyle's law says that volume is inversely proportional to pressure. Volume is inversely proportional to pressure. That's Boyle's law. While Charles' law says that volume is directly proportional to temperature. Volume is directly proportional to absolute temperature. And Avogadro's law says that volume is directly proportional to number of moles. Volume is directly proportional to number of moles. So if I combine all these three equations, all these three variations, I will have volume inversely proportional to pressure, directly proportional to temperature, and directly proportional to number of moles. If I remove this from my proportionality symbol, I will introduce a constant R. Removing this proportionality symbol means I should introduce a constant. And the constant that we introduce in this case is R, which is referred to as molar gas constant. Then V should be equal to R times 1 over P times T times N. If I multiply everything together, I will have V. R times 1 is R times T and N. You give me R Cn over P. This over 1. If I cross multiply, this and this multiply each other, I will have PV is equal to RCn. Now, if I rearrange this, now I will have PV is equal to nRT. PV is equal to nRT. This is our ideal gas equation. So this is our ideal gas equation, where P is pressure in Pascal, V is volume in meter cube, this is number of moles, this is molar gas constant, and T is temperature, absolute temperature in Kelvin. And R has a numerical value. R is given by 8.314 joule per Kelvin per mole. So the numerical value of the constant R is 8.314 joule per Kelvin per mole. So this is our molar gas constant. So this is what referred to as the gas equation, and this is how it was derived. So let's look at this example at this side using this ideal gas equation. Determine the pressure. So in this case now, solution. Determine the pressure. So pressure is question. Exerted by 2 moles. You have number of moles, N is 2. 2 moles of a gas occupying a volume, V volume is 200 meter cube at a temperature T is 50. So convert this T to Kelvin. We have 273 to it. So you have 50 plus 273. So that will give me 323 Kelvin. So if I substitute this in my molar gas, in my ideal gas equation of PV is equal to nRT, then my P is question times V, which is 200, 2 times molar gas constant is 8.314 times absolute temperature 323. So you have 200 P is equal to 2 times 3 times 8.314 times 323. So that will give me 537 0.844. Divide both sides by 200. My P will be 5370.844 divided by 200. Then my pressure will be equal to 26.85 Pascal. So my pressure will be 26.85 Pascal. So this is example of how to apply the ideal gas equation. More examples are still coming on ideal gas equation. So stay tuned to our channel at Physics with Chris. Bye.